Okay. Okay, it looks like it's okay, cool. So that's streaming. And then I'm just gonna have you present in. Let's see. Okay, we're good. So yeah, I'll minimize this uh, taskbar. But then this way, it's now recording the screen. So everything should be good now.
Yeah, okay.
Okay? You got it,
Okay.
right? All right.
Okay.
Look at that.
And how about this one? You said just click on.
Yeah, I think it's on right now.
Okay.
Yeah. So you can carry it around if you want. There's your screen.
Okay.
Okay.
I don't need. I don't much. Okay. Hello, everybody. I'm Sepide, first year PhD student in computer science. Today, I'm going to talk about a little bit about PCB design and draw a schematic, then design a PCB. And in the real world, I'm going to give you some tips to design a edge bridge. The first question is that what is exactly printed circuit boards? That stands for PCBs. PCBs are the internal components that transmit electrical signals through electronic devices. If electricity is the lifeblood of electronics, printed circuit boards are the vital internal organs. In the short way, components, if they wanted to have connection with each other, they needed a surface that we call it PCB boards. PCB boards has many layers, and so today I will show you. So this is a short clip that I'm going to show you. I skipped this part because today we are going to design, and I have an idea, H bridge, and then we draw a schematic, and then we design a PCB. So I'm going to show you a little bit clip to see how we can design a PCB. Okay, the same problem? Yeah.
Hey Meta, which of these shots should I take?
Parts and the microcontroller.
This clip is too long, and I just wanted to show you a little bit about PCB designs.
There we go. I don't know why it's not.
Parts. Once that was done, I utilized the wire function of the W13, which automatically that's with step 4 of this tutorial.
Here, when you decided to draw a schematic, you decide and you choose your elements, components, and in the lab, after this part, we design PCBs.
PCB design and ordering. For that, we firstly have to click the Convert to PCB button, which automatically throws all the component footprints into the PCB editor, shows how to connect them through the blue lines, and creates a PCB outline for us. The first thing I did though was removing the outline, because as I mentioned earlier, I needed a specific PCB size for the enclosure. To do that, I changed the measuring system to millimeters, selected the board outline layer, and used the track tool in combination with the given coordinates in the down right corner to create the correct size for the PCB. Then I moved the micro USB port, the main power switch and the joystick to the required position according to the enclosure's cutouts. To later mount the PCB, I also added 3 pads, whose size I enlarged so that M3 screws would fit through them. And with that being done, I placed the rest of the components onto the PCB. Of course, you want to separate the power parts and microcontroller part a bit, and also make sure that the pins/components that need to get connected to one another are physically close to one another,
Okay.
so that the copper trace.
So I just wanted to show you the environment of the PCB design because today we are going to design PCBs. Okay. Here I mention again how to design the PCB board. The first step is design the schematic and convert to PCB layouts. Step 3 and 4 we skip today, and we are going to build on the board because it needs some manufacture the board and assemble the components. So here I just provided some famous softwares and companies that you are able to design PCBs, Easy IDEA and KiCad, Altium Designer, and any other stuff. But today we are going to work with Easy IDEA and some companies that helps you to design your PCB very well. And you have this option to choose your layers, your components, because based on your interest, based on your budget, you can design a PCB. And I mentioned that Easy IDEA is user-friendly and free for students or any users. So what about today? As I said before, we design a H-bridge circuit to control a motor. I know you have heard a lot about H-bridge, and I believe that one of the backbone of the robotics is H-bridge because you have this ability to control the motors in forward and backward. So here I provided two circuits with MOSFETs and with transistors. And I have two options, and you can choose from here and build on the breadboard or design on the Easy IDEA. Experience, yeah. You know, we have two important components for each bridge, transistors or BJTs or MOSFETs. But based on the experience, MOSFETs are better than transistors because they switch very fast, because of their features, they are a little bit more expensive than transistors. Transistors, some simple components, you can use them. I bring here to show you, you can use them, but if you wanted to have a switch very fast, if you use MOSFETs, it's better. And you saw many HPs, they have diodes to make the direction ones, but MOSFETs has inherently diodes inside them, so you don't need it to use diodes for them. Any question? I don't know what they. Okay, imagine that you are making a robot. So if you wanted to this robot goes forward or backward, you need to design a circuit, a circuit for that. In the market there are a lot of ICs that they design all of this in one ICs. But sometimes for the first step, if you wanted to see how does it work, you use uh, this transistor or MOSFETs. For instance, when you flow the current from here, here we have a motor here, in positive and negative here. So when you follow the current, here this transistor act as a switch. This turn on and this turn on. These two, because they are in the PNP direction, as you can see that, as I mentioned, that transistors we have two types of transistor, NPN, PNP. These two is NPN, these two is PNP. So if you wanted to flow the current in this direction, as you can see the arrow, this is the forward when the motor speed in the forward way. If you wanted to move in backward, which means from negative part, the current goes through it in this way, and motor moves in the backward. And this is the same like this one. Yeah, the configuration of the transistor is so important. You should to configure the transistor in this way. PN, PNP, PNP, NPN, NPN, and the same. And you can see the arrow here. Here we have, there are two ways you can control the motor to move forward or backward, with button manually or with Arduinos. We have different kinds of Arduinos, and Arduino Nano, Arduino Uno, Arduino Mega 250, and I browse all of them for you to test it. But all of the programming is the same, so I just provided one code for all of them. So the first step, I want you to go to easyedi.com and log in, and we can start to draw a schematic. This is the environment of the EasyIdeal. Everybody log in. So in the GitHub, you may see two circuit, as I explained here, to each bridge, and we are going to design one of them. So in the left side, you can see common libraries. Here you can choose whatever that you wanted based on your circuit. For instance, for the H-bridge with transistor, we need 4 resistors, 4 transistor, 2 PNP, 2 NPN. So you just can click it and drag here. And you can just provide it for. So scroll down to find the transistor. Yeah. You can, in the, you cannot see here, yeah. In the left side, you can search and you can use common libraries. They have some common components here. Okay. Yeah. Which transistors are transistors? Go GitHub here. In the first Yeah, yeah. Oh yeah. Yeah.
Yeah, I feel a lot easier. Uh,
Because I don't have here because I'm going to shift design thing.
oh, yeah. I don't think I actually. Let's see. Or finished, you mean? Like a completed circuit?
Yeah, completed circuit. I'm going to move to.
Do you want to just log in? It,
Do
cause
you have
I don't think I have it finished. But yeah, I think if don't you have it if you log in?
any circuit diagram? What kind of circuit diagram you have? It doesn't matter. I'm just.
Oh, I don't have
Yeah,
anything.
yeah, yeah.
I haven't designed anything.
Oh, really?
Yeah.
So can I connect my laptop?
Yeah, you can either connect your laptop or you can just sign it. Do you want to just sign into Easy EDA?
Yeah.
Okay. So I'll just log out just because we're
Oh,
streaming right
perfect.
now. Yeah. So
So
then,
again,
yeah,
okay.
then hopefully,
Some. Thank you for explaining to her.
oh yeah, yeah, no,
Yeah.
yeah. She just doesn't have an engineering. So
Oh, really?
yeah. So I just figured I'd spend a little more time.
Yeah. So, what was my.
Okay, I can keep going and helping.
Yeah, yeah. Yeah. Yes. Just kidding.
So I can open up Altium and then so like this is one of the projects that I'm working on. That is so cool. The title. Yeah. So basically like this is a like it's an eight segmented antenna sensor. Okay. So this has inside of it like capacitive strength gauge sensors. So as it bends, the capacitance inside of each of these hinges changes. And so you could use that basically uh, to mathematically recreate the profile of the antenna as it's like being deformed by the environment. So you can imagine like a robot, if this is a robot, and you want it to navigate without cameras, for example, and not use LiDAR or any of these sort of systems. You could do it based on touch. But like there's not really a board like design that just exists that I could plug into that to measure all eight channels simultaneously. So what I ended up having to do is design a PCB to do that. And so let's see if there's a good example. Yeah, so like I built this little setup because we have to basically be able to like deflect the antenna, and then we need to be able to record it with like a high speed camera to actually get ground truth of like where the antenna is bending and like what the hinge angles are, and then um, so I have a PCB. I guess that's the first thing is like this PCB I designed using Altium, which is just simply a breakout PCB. So all it does is allow me to plug in the antenna to this really fine pitch connector, and it just breaks out all the capacitive sensor signals to these pin headers. They're just easy to work with. It's kind of like hobbyist standard. Everybody uses pin headers. Arduino uses pin headers. They're all spaced 2.5, like 2.54 millimeters apart. So that's just like the most standard connector size. Breadboards. Breadboard you use, you can just plug this into a breadboard. So that's kind of why I initially designed it. That didn't work. Breadboards do not work because it destroys the signal. Because it's like there's a lot of parasitic capacitance, and these sensors are like a couple of like 10 to the negative 12 farads of capacitance. So like they're super tiny. So this board, so I just designed a little board with a microcontroller on it. And so these are just integrated circuits you can buy commercially. And they're 4 channel capacitive sensors. So you put 2 of them together, you get 8 channels. And then you use I2C, which is just like a communication protocol that microcontrollers use to talk to usually integrated circuits that are like on the board. Um, and then this microcontroller, you can basically read these sensors and then spit all of the data out over the serial port to your computer. And then you just, in Python, like I can just plot the resulting data. So this is like measuring capacitive sensors. Like this is me like flicking the antenna. That's great. And then measuring the capacitive. So amazing. That's, I know, but like the thing is like when you were talking about the like perception and mapping of like asteroids. I'm like, that is so amazing. So it's just this is why it's so cool to see everybody's different stuff that they're working on. Yeah. But I can just show you that like this is what it looks like in Altium. And I can tell you have a lot of background in this stuff related to PCB. Oh, yeah, well, this is what I did for like 4 years in industry, and then I came here and I was like, I relearned the tools, like it's different tools. But so for example, like this is the readout board. And you can have fun with it too. Like you can it's slick. Yeah, right. Like it's fun because you can use other tools to draw. Like I use like Illustrator, to like draw the graphics. And then you can just import it into Altium. And you can do that in this software too. Like you can draw a board outline um in whatever software you want, like AutoCAD or like Microsoft Paint, whatever. Yeah. And then you can import it. Like I literally drew this like diagram in Illustrator and then just like imported it in because I was like, you know what? It's kind of I was drawing this for a paper anyway, and I was like, you know what? You could just like put this on the board, and then if someone's trying to like use this, they can just like look at it. No, that's yeah. So it's yeah. So it's I just have been having more fun with just like designing the silk screen for the board, and but Altium is like a really powerful tool because you can look at the 3D mode, you can like design traces, and it's like super sleek and fast, and it's very powerful. It's designed for people lay out like DDR and like RAM and stuff for like those like graphics cards. Like I'm sure NVIDIA uses this for like
Really?
drawing their GPU boards and stuff like Jetsons and things like that. So
I can't even imagine what it would look like to design like its GPU. It's
oh yeah,
like simpler than it seems, but it's
it's well. So this is like a 4 layer board,
Mhm.
but so there's only 4 layers on this, so it's pretty simple.
And each of these are in like internally baked into the layers, right?
Yeah, yeah. So like one thing you can do, I think if you yeah, so like
That's cool.
you can that's why another thing is Altium is like sweet is you can look at each individual layer of copper
Oh,
and you can see like what it is, and then I think you can there's a way to like expand these apart, but you can like literally look inside the board and like see the vias and
God,
like
that is neat.
how they're connected and like check to make sure that there's no shorts and things like that. And then what I really like is you can export this to as a 3D model.
Yeah.
And then like if you want to, for example, for a paper, so like render your board, you can export all of the traces too. And then you can like make your board like transparent and then have the rendered traces and stuff like that. Yeah, so it's pretty fun. It takes some time, but
Yeah, yeah.
like I would like to do another PCB workshop or something like that at some point.
Definitely.
But yeah, that's kind of
Amazing. I have a question.
yeah,
One that is second.
yeah, sure.
Yeah, thanks for giving this. Do you like students get access to Altium?
Yep, yeah, it's free. Everyone gets access to it. Yeah.
I've been here 3 months. I didn't know that. I'm sure you can.
Oh yeah, yeah, yeah.
3 months.
Oh yeah, yeah. No, you
Oh
can.
my God.
Yeah, they've changed it a couple of
Okay.
times.
I'm super happy.
Yeah. Have you used it anymore?
Uh,
Yeah. No, it's these are the stuff. Yeah. Just another pressure. To share something. What reform? You know. So anyone can also so what's mother? Yeah, no source is that. You really know the difference. Like you just don't get that teacher. But like, it's like as soon as it's always yeah, yeah. And my shoes no joke. She was right. Is fine, right? Yeah. It's the arms. Right. Almost the way. So there's a need to share that and share things. Share. You need to be on a lot of things. Right. It's super loads. You know, project each to whatever I'm doing those. So that everybody can share. First of all, that you're right. So first, you know, that's bottom and strategy. So you know, it's like most people are assuming she's not so expressing that. But this is on in my right but I think that we were starting with these sort of speeds, this is finding in presence of the judging reasons that three of us sometimes discuss. So I always better. Yeah, oh my gosh. You know, it's like, so it's just yeah, right now, that's awesome.
Yeah, I think there are so good at it.
So I guess that people are not your book the more than I is there's something you understand. Here you have two services in this video and two publish. Media case. You want to read the and without you coming.
But just a quick news flash. So we were about 5 minutes, I would say, to kind of wrap things up here, and then the industry lighting talks are going to be in the other room. So if you leave here in like 5 minutes, you'll have time for a coffee, or tea, or water, and then kind of make your way over there. Yes. Is it working?
So this one's kind of good. It's just three months. For me, it's not even it's games. Those pieces. It's really much. Thank you all. Yeah. Maybe it's Oh, just like it's
Do you want to do something with her? Okay. Let me ask. Because we need a laptop. So let me ask. Okay. Yeah, that's fine. That's fine. I will just take the laptop. If we can start moving in. Oh, cool. We can start moving into that one. You guys can come in. Great. Want to come in?
Next lab, yes, then break times.
It is, yeah. Just on a table for now. Parker, this is your laptop, right?
Yeah. Do you not?
Can I send you a slide deck and can you open it?
Oh yeah. Yeah. Do you want to just use it? Oh, this is also my laptop.
Oh, okay. I
Yeah.
guess.
Do you want to just use that one?
Yeah, it looks fine.
Okay. Yeah. If you just email it to me, I can.
All right.